Hello, I'm Kevin Houston, and this is my second video on common mistakes in mathematics. In this video, we'll be looking at division by zero, and in particular, why 1 over 0 is not infinity. Off we go.
What happens when we divide by 0? Well, you may have seen a proof of 1 equals 2 to exemplify that we should not divide by 0. Such an operation is easily missed, so be vigilant. One incorrect argument for 1 equals 2 is as follows. Let a equal b, then ab equals a squared, since a equals b. ab minus b squared equals a squared minus b squared, by subtracting b squared from both sides. b times a minus b equals a plus b times a minus b, just by factoring. So b equals a plus b by dividing both sides by a minus b. So b equals 2b as a equals b. In other words, 1 equals 2 by cancelling b. The division by 0 happens when we divide by a minus b. Since we assume that a equals b, this must be 0. That is where the argument goes wrong. This throws up the question, why can't we divide by 0? Let's answer a different question. Suppose we could divide by 0. Then what do we get when we divide by 0? For example, what is 1 divided by 0? We could argue as follows. Look at 1 over x and let x get smaller and smaller. One can see that as x gets smaller, then 1 over x gets larger. Therefore, we could define 1 over 0 to be infinity. Mathematicians note infinity by that round symbol, looks like an 8 on its side, so we are claiming that we can define 1 over 0 to be infinity. At first, this seems fine. After all, we can see that 2 divided by 0 must be 2 times 1 over 0, which is equal to 2 times infinity, which is infinity. It makes sense that 2 times infinity is infinity, doesn't it? If I take the union of two infinite sets, then I get an infinite set. We can do this for 3 times 1 over 0, 4 times 1 over 0, and so on. The problem comes when we consider 0 times 1 over 0. 0 times anything should be 0. So, 0 times 1 over 0 equals 0 times infinity equals 0. Okay, so we're happy with that. But on the other hand, the rules of arithmetic allow us to cancel. A times b over a equals b. So we must have 0 times 1 over 0 equals 1, just by cancelling the zeros. Thus, using two different methods, we have found two different values for 0 times 1 over 0. That is, 0 times 1 over 0 equals 1, and 0 times 1 over 0 equals 0. In other words, by allowing division by 0, we produce an obviously false equality, i.e. 0 equals 1. The point is that if we allow division by 0, then we cannot have that 0 times x equals 0 for all x, and that a times b over a equals b for all a and b. Therefore, if 1 over 0 is given a value, even if the value is infinity, we quickly end up in a tangle. Now, as mathematicians, we can choose the rules we want. Not all choices lead to a useful theory. Indeed, you can construct a theory that defines 1 over 0 as infinity, but then you have to lose useful rules like a times b over a equals b. In the case of infinity, we should treat it not as a number, and so subject to algebraic rules, but as a concept. More is said on infinity in chapter 30 of the book. One interesting idea is that some infinite sets are bigger than other infinite sets. In other words, there are different sizes of infinity. Okay, let's have some conclusions. Don't divide by 0. 1 over 0 is not infinity. Thanks for watching.